we'll begin the laboratory of the week number 3, Introduction to Unix Operating System. Right? So you might have gone through the Google class, right, and seen what all the assignments and all given, right? So we have uh, four assignment. First one is theoretical, second one lab exercise 1, 2, right, and third one is study of access permissions and all. Now I have given also the list of programs which you can go through that. So in the last class, in the last laboratory, we have seen execl, right, and it's a variation. Along with that, we have seen p error, right, exit, success, exit, okay, failure, return value, constant, right, what is the use of that, how it helps in portability, all that things we have seen. Today, now look at that learning material and that self-learning drive for the fork and its variation. These are the 4 programs we would like to see it, right? This is where do we stand for the laboratory. I hope that you all people have executed all the programs, command line arguments, displaying PID, parent ID, process ID, right? Then simple fork system calls, right? All these things you are done. Hima Rashmi, am I right?
Yes, sir.
Okay. Now we will get into the extended version of the fork, vfork, right? Today's important question is what is the difference between fork and vfork? In fact, the same question was asked, similar question was asked in gate examination also. And this is very important from the placement perspective. So all of you see this, right? We'll spend some time, right, on this. Now let's get into the Unix environment. My screen is visible? The Unix screen?
Yes, sir.
Yeah, right. Himarashmi, regularly you keep on acknowledging me so that I can go ahead with this. And if anybody is waiting, you inform me also. Now look
Yes,
into
sir.
that. Yeah. Now look into that. Just recapturing whatever that we have done, right? So we know that int PID we were using. This is not the right thing. PID underscore T, PID I had to use. PID underscore T, you all people know about that. Then when you fork, okay, it returns a value, right? It is less than 0 means it's an error. And we are using printf and exit. This is not the right practice. Exit 2, exit 3. What is the guarantee that when exit 2, number 2, okay, has the same meaning in other implementation of a same Unix by different vendor and all, right? So printf is not good things. There are, okay, system calls available for these two. Already you have seen it. How to use those things, that becomes a good programming practices, right? And you know that the PID, whatever this we are using, okay, its a value will be 0. Now when you call fork, right, the immediately after that, whatever the line is there, this will be executed by both parent as well as child, right? That's the interesting thing, right? So this code, whatever you are seeing, it will be executed by both parent and child. So I need to distinguish, because parent and child have a same copy of that, copy of the program, right? Not the same program, copy of the same program. So I need to distinguish between the child and parent. So PID variable value will be 0 in case of a child, right? It is a non-zero in case of the parent process. You can print the value and see it, right? Now see, when I distinguish, this is the child process and this is the parent process. Both copy will be there in both child and parent, but I distinguish so that child will execute its part, whereas parent will execute its part. Now look into that, right? So who will execute first? By operating system. These are the two different processes, right? Parent process and the child process. Who will execute, right? So it is up to the scheduler how operating system schedule with this. We don't have a control on this, right? It may be a child process may run first, or it may be a parent process may run this. Assume that parents run first. Look at the highlighted things. I'm forcing the parent to sleep for, okay, 2 seconds, right? So that there will be a context switch, so that the CPU, okay, picks the child process and start executing. I'm forcing the child process to run by okay, making parent to sleep for 2 seconds. Sleep is another system call which make the system, I mean, process, calling process to sleep for the whatever the integer number of seconds mentioned in that. So the parent child process will execute first. It will display its PID and its parent ID, and afterwards there is again a context switch. Child is completed. It returns, right. Then parent will execute that, and this is how I am forcing the child to run. Okay, if you remove this, if you put the comment here, right, okay, either a child may run first or a parent may run first, we don't know, right. Now that is a problem. If a parent runs first and exit and child remains without a parent, okay, then that is a okay, difficult situation in society, right. That is a difficult, okay, this one. So we'll see that what all these process are called, right, this later, not to put everything at one shot, right. So when you run this, right, okay, you will find that there are two things. Child will say that when my parent is 2995 and myself is 2996, and look at the parent. Parent will be, it says that I am 2995. Thereby, see, look at that, the marking, whatever I'm doing here. Thereby, right, a child and parent relationship you can see. And these are the unique IDs generated, assigned by the operating system every time the program is run. It is not same all the time, like your USN number, right? Understand this, right? US number is fixed one, today, tomorrow, day after tomorrow, until you complete your course, or okay, lifetime, right? But it is not so here. As long as the program is running, it is same. Once the program terminates, different things you get it. Now another interesting thing you will see here is that you do the ps minus c, ps command. Okay, it will list all the, it will list all the, okay, process running in the Unix operating system, right. There has to be some grandfather, you know, great 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 grandfather, Lord Brahman. He is the father for everyone, right. So similarly, right, look at that. Init is a process, right, which is the, okay, Brahman, right, a great great grandfather for all. Now look at that, the parent process here, it says that one parent process says that its a parent is 2904. You will get a different number in your system. So whatever the number you get, try to see that one, what is that? So the 2994, when I was running this, I got, okay, this here 2904. When I looked at that, is a bash. It is a shell script. It is a shell, right, which will receive your commands, everything, and submit it to kernel, executes it, and gives the result back. In the last theory class, we have seen command interpreter. So this is a command interpreter. We'll see this, all these things in third chapter. From that we will begin, right. So today is one more lesson, that ps command you will be executing to list all, and whatever the process id you get for a parent, it's a parent, right. It will be the shell that you are running. It is not only the, like a bash, there are many other shell, okay, that system uses, right. So which one you have configured, which one you have used, that you will get it. Try to check this, right. It's a command interpreter. At the dollar prompt, whatever it you receive, whatever you send, there has to be somebody to receive that. So who is somebody? Command interpreter. It receives everything. It is an interface between you, user, and kernel. The kernel is a core part of an operating system which has process management, memory management, device management, file management, everything, security, safety, okay, privileges, right, all system calls it run, everything it does, scheduling it does, right. Scheduling in the sense, when in a multi-programming, multiple programs you submit it, it is something like you go to doctor. There are many people, right, waiting outside. They are all the process. And somewhere, the clinic manager, right, you'll call somebody's name, right, Mr. Ramesh, you get inside, doctor is calling you. So he schedules patient, right. And sometimes a patient goes inside, come outside immediately, purchase medicine, and again they get inside. All this is called swapping in, swapping out. They're called context switch. They're called context switch. All these terms we have gone through, please, okay, look into that. And in next study session again we will revisit quickly the memory management, process management and all, and thereby we complete the first two chapter by going through the different system calls. And yet I need to go through directory listing related system calls and all, that we will spend the next week whole. So that first two chapters are meant for internal exam 1. Both theory and laboratory, they are connected. This course doesn't have a laboratory separately. It is an integral part of theory 202 model. It doesn't have a lab exam, right? All laboratory practice based session, whatever you do, they are the part of internal exam 1 as well as semester end exam 1, right? But you will be submitting reports and all. So, Manoj, Himarashmi, this is where we do stand, right? So, shall I go to the next exercise? Shall I go to the next exercise?
Yes, sir.
Yeah. Okay. The variation of this 40-2. Not this 40-2. No. 40-1. And I've told you all your programming assignment submission to be done like this: author, USN, semester division, date, problem statement, all theory, all system calls, its syntax, input parameter, return value, description of input parameter. Even if it runs theory part, one page, no issues, you can run it. References, all book, all manuals, all okay, web pages, everything you refer, write it here. So this is by default a comment for every program, whatever you write in any of the course, any of the laboratory. Please follow this. This is the standard, okay, which you are supposed to follow. Now look into new learning in this, right? This was a question asked in the gate examination. So look at that. When you create a child process using a fork, child get a copy of the parent's data space, heap and stack. A program uses heap, stack, its own local memory, global memory, right? All the things, right? We will see the structure of the program, how it appears in the memory in the next class. Now I said it gets a copy. When child get a copy of a parent, then whatever the child modify, it doesn't reflect in the parent's data space. That's why parent and child do not share these portions of memory at all. Are you getting it? But it get a copy of that. Got it? So this was a question asked in the gate examination, and this is the good question for the placement related technical interviews, right? Or technical written test, right? So Himarashmi, do you appreciate the kind of exercise we pick and do it? Himarashmi?
Yes, sir.
Yeah, that's a good thing. Manoj, that's a good thing, right? So this is the study we'll be doing that. Is it so? Right? So now look into that. I declare one global variable. I'll tell you about the global variable, local variable, all variable concept of C program, right, in the next class, and tell you details of that. Study this. Then you have a command line arguments we are not using. It is a standard procedure we put it. So I'm declaring one local variable inside the main function, right? They are called automatic variables. Got it? We'll see the storage classes and all later. Then I'm using a PID variable. It is again a local variable to main, right? PID underscore T, right? What is PID underscore T? Already we are seeing. PID underscore T data type is a signed integer defined in this particular types.h of this operating system implementation, right? It is signed integer in my Ubuntu. It could be some other integer in other implementation. So my program doesn't work, okay, if I use signed integer PID. If I use PID underscore T, its definition is different in different implementation of types.h. Hence my program become portable, my program works. How do you make your program portable? This is one best example. Got it? Right? So please look into that. We already gone through. I put the value, 113 in this. Now I'm making an attempt to fork. I use a P error if fork fails to create a child process. Right? Now child and this one, what I'm doing is child is incrementing global variable and local variable, and parent is sleeping. That's all. So the child is forced to run first. And remember, I've distinguished after the fork, whatever is there, entire thing is shared by both child and parent. And I've distinguished child and parent, what to execute. But I have not used that distinguishing if then else for this. So this highlighted things will be executed by both parent and child. Remember. So child execute first and it will display in a highlighted line, right? The my PID, my parent ID, and the value of the UPK variable, value of the variable VAR. And parent also execute the same line when it comes out of the sleep system call, right? So both will execute these highlighted things. Now, but look at that. What are the value of UPK and VAR variables used in this? See, child has updated, incremented both and displayed. But this incremented value of the child are not being reflected in a parent, and parent will have a initial value only because whatever the changes child do, it doesn't reflect in parent because see here, child get the copy of the parent's data space, heap and stack. Parent and child do not share these portions of the memory at all. Getting a copy is different. I have a book. I take a Xerox copy and give it to you, Himarashmi. You write your name on that book. Whatever your name you write on your book, it doesn't get reflected in my book, though your book is a copy of my book. Right? Are you understanding this? So this is the study you people have to do it and hence prepare for the placement. And this you can understand only you play with the program. Play. Initially you may find it difficult. No issues. No issues. A best example that don't run away from that. It is something like a banana plant. You cut the banana plant, again it grows. You cut the banana plant, again it grows. Right? Don't give up. The day you give up doing anything, right, that means you are lost. If you don't understand, do it. If you don't understand, do it. Until you understand it fully, you own it, don't give up. That's what the banana plant speaks all about. Got it? Any questions now? Any questions? Any questions? You may get a 1 or 2 marks question in the examination. Or you'll be asked to, what is the difference between the fork and V fork?
Sir,
Write a C program to
sir,
distinguish. Okay, Manoj.
sir, when force system is called, sir, the parent process and the child process both run parallelly or one
Yes,
after the others.
you don't have a control on that. Who runs first? You don't have a control. Operating system will schedule. For example, consider that myself and my son, we will go to the doctor. Both are patient, assume. We go and sit outside, right? He's my child, right? Who will be called inside first? Depends on the manager of that clinic, the order in which we are registered. He will call my son first, he will get inside, or he will call me. Who will run first, whether the parent or child? We don't have a control, right? Got it? So that's operating system will decide based on the priority, based on who has come first, right? All the things that we will see it later. Manoj, did I convince you at this stage?
Yes, sir.
Okay. Any other question at this stage? Any other question at this stage? Himarashmi,
There is question.
Parent process ID the same.
Himarashmi, please read. Any question? Himarashmi, read a question from your chat box.
So
Look,
there is a question. Why are the parents' PID and child's PPID the same?
now look at that, right? Okay, now consider this is the child. Okay, assume that you are a child. Your USA number is 3407, right? Your father, his ID is 3406. right? This entire line displayed by you, Himarashmi. Himarashmi, your ID, citizenship number is 3407 and your father's citizenship number is 3406. This is displayed by you. But your father also is running. He says that I am 3406, correct? No? You are the daughter of your father, right? You said 3406 is my father. Your father says that I am 3406. So this is the connectivity. Are you getting it? And your father says that his father is 2455. And 2455 is a grandfather for you. 3406 is a father for you. And 3407, okay, you yourself. Himarashmi, did you understand this?
Yes, sir.
Right? It has to be same, no? Parent ID of a process, right? And the parent's PID will be same, no? So the one which I highlight, these are same. Then only there is a relationship between the parent and child. Look at that parent says, I am my process ID. Look at that child says, my parent ID. Right? These are to be same. Right? Yes. Any other question here? Any other question here? Shall I go to next step?
Sir, I wanted to ask what is the use of the two copies being created? Like, why do we create two copies?
Oh, that's a great. That's a great. Right? Well, I will tell you in depth, okay, in a classes to come. But look at that ahead of time. So when you are doing a function in your home, right, your father, right, is overloaded. Then what he will do? He'll call Himarashmi, okay, take care of purchasing all eatables required for the kitchen room. He will call your brother, say that when you do this, right? So why it's being done? Because the work is distributed to different children, right? So that parallelly they can execute and get the result, okay, quickly, right? So it is related to parallel processing. See, we talk about the multi-core, am I right? We talk about the multi-core. There are multiple core and there are multiple CPUs, right? When a program is submitted, all these things will run on different core, different process parallelly. Are you getting this? Right? So they run, right? And the you that's how the you can parallelly do the things and optimize. Quickly you can get a result. You can enhance the performance. Are you getting it? So that's why the child process.
Yes, sir.
Right? Please remind me. I will take beyond the syllabus some diagrams in the next class. Okay, I'll explain about this particular thing which we have a little bit gone through. We'll get into this. Is beyond the scope of this. Thank you. Good question. Next, this is the way you people have to think that will help you people for placement related preparations. Good.
Sir, when for system is called, sir, the in child process, the execution from next line of the fork system takes place, or from the same line takes place.
Now, when you call fork, this is the entire fork. Okay. When you call the fork, the next thing is this, right? These things are being executed by both parent and child. Got it? Next line is this. Since you are using a right fork and checking that one and all is a part of all that things, right? Understood, right? So in the previous example, assume that I'll remove this. Okay, if I comment this and simply if I put, I may use fork, very crude way of doing it. So like this, right? Now consider that this part of the line is not there, right? Immediately after the fork, whatever that is there, that is being shared by all, right? But this is not the good programming practices. Every system call you call, it returns a value and report error. It may so happen that the system may fail to create a child. System may fail to create a child process. At the time, you have to report that fork error and it gets terminated. Right? You can use exit. Right? This is the wrong way of doing it. Okay, best way of doing it is exit. Okay, exit failure. Right? So this is how you have to do it. It fails to create a child process. Any questions? I think I've answered your questions.
Sir, some students are waiting, sir.
I've admitted. I've admitted.
Thank you, sir.
Any other questions?
So there is one more question.
Hmm.
Why do we use exit function?
Oh, why do you use exit function? Okay, whenever you make entry, you need to have an exit. First thing. And look at that. Okay, here in the main program, you are using main function also return int value, no? Right? When you fall end of your program, naturally you have to exit. And in between, abnormal things you find. For example, I'll tell you, okay, your father has asked you to go to the market and purchase, right, Amul ice cream. Got it? This is a program. You go to market, purchase Amul ice cream, come and terminate. Over. And that is normal termination here. Right? But why exit is required here? Why exit is required here? Why you are main now? Right? Himarashmi, you are main. You come back again, report it to your father that I purchased Amul ice cream. I didn't purchase. That is the reason why this int you will put it. And every program will return a status to an operating system. What? How does it terminated? Is it successfully terminated or not? Second thing, this is normal termination. Program terminates here and it returns value here. But exit 0 is not right thing. Exit success. Right? Now, there may be abnormality. You go to the market to buy Amul ice cream, but you open your pocket and see that one, there is no money at all. What is that you do? Right? You terminate in between, you come back. Am I right? You terminate there. You stand in front of the shop and say that I need, okay, 1 kg Amul pack, but you put your hand in your pocket and see that money is not there. Then you tell the shopkeeper, no, 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 sorry, I forgot to bring the money. You terminate there. You terminate. It's abnormal termination, failure. So this is the one. That's why you need exit. Exit are of two type. One is normal exit after completing successfully. Other one is abnormal exit of failures in between. And that makes program robust, strong. Very good question. What is a robust code? You go to the shop and order 10 kg of Amul ice cream, right? And they give packet and put a receipt. Then you put your hand in your pocket and find that money is not there. Oh, that is a horrible thing, code. So what you do is that you ensure that money is there in the pocket. Then order, right? So that is a robust code, right? So you have to ensure that otherwise the subsequent line may result into errors. So whenever you detect an issue, right, you report it and terminate. This is one approach towards writing a strong code, robust code. Strong code, robust code. Any question? Himarashmi, did I answer your question? Why exit is required?
Yes, sir.
If I don't put an exit here, look at that, it continues. And it may be wrongly written a code so that it may corrupt some other things. It may corrupt. Okay, for example, I'll tell you, okay, PID equal to order Amul ice cream. Now, Amul ice cream, when you order, it will the owner will ask you, do you have a money? Assume, right? That question asked by the owner of the shop is PID. You didn't check your pocket. Simply, you said that one, okay, make a receipt. That means make a receipt, continue. Then what happens when you make a receipt and then you say, I don't have a money? Program, there is a failure, catastrophic failure. Anything harm may happen, right? Had you tested earlier when shopkeeper said, do you have money? By checking your pocket, you could have written a strong code, ensuring that receipt, everything is all right. Otherwise, you have a quarrel with owner. Owner says, oh, okay, freeze the receipt, you have to pay and go. And you say that I don't have money. But it same thing happens in the code also. A wrong code, I mean, code may unnecessarily do something which is incorrect, depending on how you are written in a highlighted part of this. Himarashmi, is that clear?
Yes, sir.
Any other question? Any other question? So now what I'll do is, if I've given a hand holding on fork, but V fork is something different. There is another variation of that. I've given some theory aspect of that here, right? Same program, same program. Instead of fork, I use a V fork, right? And I have used execl. You know what is the purpose of execl, right? I wanted you people to study this code and understand and do it. Everything spoon feeding should not be there. A learning should happen on your own. Self-learning is the best learning. So the variation of the fork are given here, same program. I given some theory, important from examination point of view, placement perspective, gate examination perspective. I will give a little bit more handholding. V4 create a new process, but without copying the address space of the parent to the child. Child, the purpose of the child is to call exec or exit. While child is running until it calls either this, child runs in the address space. Until 1 year of your age, right? You are with your mother. You all people, we all people. The V4 guarantees that child runs first until the child calls exec or exit. When a child calls either of these, parent resume. I've given some hint. You go through this, right? Is a variation of the V fork, right? Right? The child doesn't get a copy of that. Child runs within the same address space of parent until you call this. Once you call this, a new program will come and sit in a child space. Are you getting it? Then what happens? What is an output? What is an output? How do we get it? Right? Please study all these things and self-learning, and we will stop. Now we are stopping. It means that the remaining time you people have to keep on trying as if the laboratory is running your home, run it. Don't shut down the system and keep on doing all housekeeping work in your home. Himarashmi and Manoj, both of you unmute. Himarashmi and Manoj, both of you unmute.
Yes, sir.
So in the regular laboratory also what we do is we give certain instruction and you will be asked to do it. Now remaining time of 1.5 hour or 2 hours, whatever it is their lab period up to 10 o'clock, right? Continue trying this in your home. And with this, I'm going to stop, right? This V fork is the self-learning exercise. And please look into your okay. 1 minute. Right here the exercise have been given. You can get it. And if you look at the assignment, laboratory assignment, if you look at this, it says that, okay, write a C program to demonstrate the use of EXEC and vfork. Self-learning exercise, study the principles and other aspects of system calls used here. Refer Unix manual for this. Study the variations of EXEC and all. Okay, another thing is, right, how, right, fork is different from vfork. Okay, yes. So this you will be getting a question on this surely in the IA1 and semester end exam. What is the difference between fork and vfork? How they are different? Write a C program to demonstrate. 10 marks. Got it. So I think you will be in the position to do this, right? Then 1 minute. Assignment number 4 is very simple. Study all the commands. You can add some more thing also. PS, okay, this, then PWD, whatever we are saying, print working directory, print working directory, right? Then it has been said, study the access permission of a given file, right? And change mode is the main thing, okay, which you'll be in the position to do it. I have demonstrated to you. You can refer the video and do it, right? These are the 4 exercises which you'll be completing by September 30. If you are done early, submit it. But how to submit, what kind of comment, what kind of documentation to be done, I've told you. Okay, please go through that, right? So shall we stop here, Himarashmi and Manoj, so that you can continue doing laboratory? Himarashmi, Manoj.
Yes, sir.
Right. If there are no questions, then I'll stop. Right. I'll stop sharing the screen. 1 minute. Wait. Around 47 students have participated. A low attendance. It is not a good thing. Okay. Ask all other people to get into. Right. So I will close this meeting. If there are no questions, I'll close this meeting. I'll end the
No
meeting.
questions,
Manoj,
sir.
shall I end the meeting?
No. Yes, sir.
Okay. Now you, all of you, continue doing laboratory. Bye.